Okay, this video is going to cover the distribution of the sample mean for the normal distribution. So we're going to continue working with normal distribution, and we're going to kind of review a little bit of what we've already done. So up until this point in the course, we've been working with samples that are essentially of size 1, and we calculate a z-score for the normal and determine the probability of getting that value using the idea of the empirical rule and the probabilities associated with the standard normal z-scores. You will remember the z-score is centered on 0, +1, +2, +3, -1, -2, and -3, and that the normal curve goes from -infinity to +infinity. Well, the distribution of means works much the same, and just to review what we've done, our first question is, consider the distribution of IQs as normal with a mean of 100 and a standard deviation of 15. What is the probability that a person has an IQ less than 90? So we would sit there and go, all right, what is the probability that X is less than 90? And we sit there and go, okay, my equation is z equals x minus mu over sigma. And we want the probability that z is less than 90. We said our mean earlier, we said our mean was equal to 100, and our standard deviation was 15. 90 minus 100 over 15. And then we go ahead and calculate that out using a normal CDF. So let's do that real quickly. And actually, you know what? I need to back up and do something. If we were drawing a diagram of this, which we always need to do, our mean is 100, which is right here. 90 is less than that. And I'm shading off to the left, so I'm shading off to -infinity. So that means I'm working with a norm CDF where my lower is -infinity, my upper part of the shading is 90, my mean is 100, and my standard deviation is 15. So second vars, normal, CDF, lowers -infinity, so I'll load that up with a bunch of 9s. Upper is 90, mean is 100, standard deviation is 15. When I calculate that, I end up getting a value of 0.2524. At least I hope I do. Let me do that real quickly one more time. Second vars, normal CDF, 90. Yes, 0.2524. And please note I truncated. So this would be my answer, and this would be my work shown, and we'd be very happy with that. Now, please note that we were working with a person. That means my sample size was just a sample of 1, because a person is just an individual. And then we go on and we go, well, what is the probability that a person has an IQ greater than 117? All right, so we want the probability that our X is greater than 117, which yields this, the probability that Z, because we're always using that z-score formula, is greater than 117 minus 100 over our standard deviation of 15. Drawing my diagram, we have a mean of 100, a standard deviation, this goes to -infinity, this is going off to +infinity, and our X value, the value we're interested in, is 117, and it's greater, so we're shading up, so we're shading off to the right. So my calculator part would be norm CDF lower of 117 all the way to positive infinity with a mean of 100 and a standard deviation of 15. So let's go ahead and run that one. So second vars, norm CDF. And now the lower part of my shading is 117. Oops, 117. The upper part of my shading is positive infinity, so I'm going to load that up with a bunch of 9s. My mean is still 100, and my standard deviation is still 15. And I end up getting 0.1285. And this will be my work shown. Okay, so as we mentioned above, we were working with a singular value or an individual or the probability of 1. But what happens when we increase our size and sample size? What if we're doing with a sample size 5 or 10 or 100? Well, our formula is going to change slightly because we were working with this formula. Now it's going to shift to this, where X bar is an average. So we went from X to X bar. So this is going to be the sample average. And then we're just dividing by the square root of the sample size. Now I know this looks really ugly because formula-wise it kind of is. Difficulty-wise, it's not. It's going to, the calculator will do it all for us, but we'll be using a different function on the calculator. All right, and so you will notice that the X changes to X bar because we have changed from working with a singular value to working with an average of values. Or we may say use the word mean, or we may use the symbol X bar, all right? And then the standard deviation of the population will now be divided by the square root of n, because we're working with means. So when we're working with this distribution of means, the standard deviation will be divided by the square root of n. Now, one thing I forgot to mention is this whole time we are working with the underlying distribution is normal. We're still working with a normal, so at this point we're not too concerned about sample size. All right? So how does this apply? Well, first off, the empirical rule, when we apply it to the normal curve, said we had a mean of 100 for the IQ, standard deviation of 15. So one standard deviation above would be 115, 130, 145. Going down, -1 would be 85. 2 standard deviations below the mean would be 70. Someone with an IQ of 70, and 3 standard deviations below would be at 55. And as always, this is going to negative infinity, and this is going to positive infinity. Now, consider the above situation, both with a sample of 9, so it's 29, let's scratch that out, of 9 as opposed to a single value. We would still expect the sample mean to be 100. So the sample mean will never change. So the sample mean doesn't change. You might want to write that down. So we're going to say the population mean equals X bar, or the population mean equals the sample mean. That's the belief. All right. All right, so we basically are claiming that it's still going to be centered at 100, but our standard deviation is going to change. Instead of just being 15, it's going to be 15 divided by the square root of the sample size. So the population, which was 15, divided by the square root of the sample size, which we said was 9. Remember, we said it was 9 and not 29. And square root of 9 is 3, so 15 divided by 3 is 5. So if we had a sample of size 9, our standard deviation of the sample would be 5. When we do that, now our graph gets a lot taller. Now these aren't to scale, but I tried to make them as close as I could. So now instead of having a standard deviation of 15 up here, we're working with a standard deviation of 5. Why? Because this is for the X bars, all right, where we have a sample of size n. So now instead of going from 100, let's see if I can scoot that up, from 100 to 115, we're going from 100 to 105. So we're counting by 5s. We're up here, our standard deviation was 15, and we're counting by 15. The area under the curve still stays the same at 1. Okay, the area under the curve still stays the same at 1. So originally on the first page, we calculated the probability a person has an IQ of less than 90 is 0.2524. What happens if the probability that a sample of 9 has an average of IQ less than 90? So now we're not worrying about the probability of X, we're worried about the probability of X bar being less than 90. All right, probability of X bar less than 90. And the reason I know this is they say a sample of 9 have an average. So we have a group with an average. So group and average tells me I need to be using this formula, assuming it is normal. All right, well, we've already told you above in the earlier part of this problem that it's normal. So X bar minus mu sigma divided by the square root of n. So what all do we have? Because we need to kind of identify all those parts. Well, in this case, we already identified X bar. We know that the population mean is 100. We know the population standard deviation happens to be 15. And our sample size is 5. And I don't have that on the screen. Now we're going to use this formula, and I'm going to plug in. So the probability, I should go ahead and draw this out before I forget about it. We have a mean of 100, and we want to know the probability that the IQ is less than 90. So our graph looks essentially the same. Technically, I should have made it taller, but I'm not that good of an artist, so I don't worry too much about it. So the probability that Z is less than 90 minus 100 over 15. So far, everything's exactly the same as what we wrote before on page 1, except now I'm going to be using divided by the square root of n, which we said our sample was a size 9. All right, so that sample is size 9. So let's try this out. Well, now we're no longer going to use second bars. You could, but it's more difficult. I'm going to show you a better place for this, and you're going to need to go stat, test. So stat, test, z-test. That's what you're going to need to use. So here we go. Stat, arrow over to the word test, make sure test is highlighted. And we see z-test, so I'm going to press enter. Well, make sure the word stats is highlighted. If data is highlighted like this, if data is highlighted like this, arrow over and make sure that stats is highlighted. All right, so our mean was 100. That was the population mean. The population standard deviation was 15. The X bar was 90. And n, our sample was size 5. Now ignore what it says and just look at the shape of the arrow. Well, we said X bar is less than, or we shaded down. So we want to make sure that we have our inequality facing in the same direction. So because we have this, or because we shaded down, we need to choose the one that looks like that. And then we're going to press calculate. And I end up getting, so that tells me the probability that Z is less than negative 1.49 equals, our probability is 0.0680. 0.0680. And that would be my work shown. Now, I probably should have taken this out and made this 0.7. Take it to the 4 decimal places. Okay? So essentially it runs almost exactly the same way as what we have to write. But when you go to the calculator, we're going to go stat test and then Z test, press enter. So let's try it again. Originally, we found that the probability of an IQ greater than 117 is 0.1285. We calculated that on the first page. What's the probability a group of 9 have an IQ greater than 117? All right, so they want to know that the average of that group is greater than 117. So the calculator is going to say, it's going to ask us for our mean, and our mean we know is 100. Our standard deviation happens to be 15. Our X bar, the part that we're interested in, is 117. And our sample is still size 9. So we want the probability that X bar is greater than 117. We want to know the probability that that group of randomly selected people have an average IQ of greater than 117. That doesn't mean every individual has an IQ greater than 117. It just means the group does, the average of the group. So we're going to, because we have multiple values, we're going to be using X bar minus mu sigma divided by the square root of n. So this is going to be the probability that Z is greater than 117 minus 100, should have a minus sign, over in 15. Well, that's exactly what we wrote on page 1, but since we have a group, we need to divide by the square root of 9. All right, so drawing our picture, it's exactly the same picture as we had on page 1. Technically, it should be taller and etc. But like I said earlier, I'm not that good of an artist. I'm not going to worry about it. And our mean is at 100. This time our X bar is at 117, and we are shading up. So stat, test, stat, then test, then Z test, press enter. Stats needs to be highlighted. Our mean is 100. Our standard deviation is still 15. Our X bar in this case is 117. Our sample is size 9. And we're going to make sure that because we are shaded up, make sure that's shaded that way. So we make sure that we have the inequality of the greater than, because this was greater than, so we need this to be a greater than symbol. And we press calculate. And I end up getting a pretty small answer. I end up getting an answer that says 0.0003. All right, 0.0003. And I need to check my work real quickly. Yes, 0.0003. I made it, so this is 0.003. I need to go back up to the one above. So this right here would be my answer. This is correct. This is everything done correctly. I need to go back up and rerun the previous one because I made a data entry error. So stat test, Z-test, press enter. 100 for my mean, standard deviation of 15. X bar needs to be 90. My sample should be size 9, and I need to make sure I have that highlighted that way as a less than because we shaded that way. And I end up getting 0.0227. All right, so this was calculated incorrectly. I ended up typing in the wrong number there. So this is 0.0227, and I apologize for that. Okay? All right, so keeping in mind, all we did was work with a normal curve. So we worked with a normal curve, and so we were working with a normal curve, and our underlying distribution of means, all we did was divide by the square root of n. We weren't using normal CDF, we were using stat, test, z-test. All right, that'll conclude this one, and in the next video, we'll talk about what happens if the underlying distribution wasn't normal.